Hello and good morning, everyone. We'll be starting the webinar in another 5 minutes. So we'll be waiting for everyone else to join in, and we'll start around 11 a.m. sharp. Hello and good morning, everyone. We will start the webinar now. First of all, thank you for coming to this drone tech, industrial drone tech in oil palm plantation webinar. So for today, my name is Tengku Afiq, and I would be the moderator for today. And then speaking with us, with us today is Jayang from the sales or commercial team of Poladrone. So Jayang will be the one who's presenting about the usage of drone technology inside oil palm plantation. And before we start, before I pass the mic to Jayang, you can, if you see on your right hand side of the screen, there's a Q&A chat box which you can use to ask any questions that you might have, and then me and Jayang will answer the questions throughout this presentation. So without further ado, I would like to pass the mic to Jayang.
Hello,
Hello.
hello. Yep. I think there's a background sound from your side.
Okay. So.
Yep. All right. So good. Yep. Okay. Thank you, Afiq, for the introductions. So my name is Jayang. I'm coming from Poladrone sales team or the commercial teams. So basically today's we're gonna talk about is the oil palm plantation for the drone usage. So let us look through our agenda first, what we're going to cover for today's webinar. So pretty straightforward, our agenda. We'll start off with our background, which means Poladrone background. I will explain about it. And also I will do some introductions for UAV to all the beginners or the newcomers who are not so familiar with drones. And then in the third part, I will talking about the applications in oil pumps. So basically there's two parts that I will explaining. So first one will be analytics and the second one will be the automations in oil pump industry. And last but not least, I will talking about our service. Basically, I will talk about what kind of service can provided by Poladrones and how we can help you in oil pump industry. So next, so start off with our background. So basically Poladrone is the tier 1 distributor for DJI in Malaysia. So basically we are distributing DJI Enterprise in Malaysia and also other many leading payloads such as the Santara and also Fleur for different industry usage. Then we are founded in 2015, which focusing in agriculture mapping and inspections activities in Malaysia. And also we're providing the enterprise drone solutions, including the drones hardware, sensor, and also the analytic from the software part. So which is a total solutions. Next, so up to date, we have our team have mapped up to 500,000 hectares of and also process analysis for our clients. Apart from that, we did have our manufacturing plants that manufacturing for our own spraying drones, which in the later one I will cover a bit for the spraying drone from our team. And also we did have a sister company called Drone Academy Asia, which trains and also educates the pilot for the drone usage for different organizations. So next, let us start with introductions of UAV. So what is UAV? UAV is called as an unmanned aerial vehicle. So it's a type of aircraft that operates without a human pilots on board. So commonly known as drone. So to have a complete UAS solutions, basically we need to have 4 parts. So the first part will be the platform. So platform normally we are referring to the drones, and then come with the payload itself. So payload normally we are refer to the cameras or other payloads like that. I will explain it later. So and also software. So software is kind of like the brand of the total solutions. So to have the complete solution, last but not least, you need to have a very experienced operator as well to fly your drones and also complete your missions. So to have a complete solutions, definitely you need to have 4 part of the objects in the slide. Then after that, next we're gonna talk about is what kind of platform that is existing. Next slide. Yep. So for what kind of platform is existing in the drone industry is that they have three types. First one will be like fixed wing. So fixed wing, you just imagine it is something like the aeroplane. So they need to take off like an aeroplane as well. So they need to have a very long way to take off. And then second one will be the multi-rotor. So multi-rotor is something like the helicopter concept. So it can very easy take off in the restricted area. And then there's a hybrid version called VTOL of the drones, which is a combination of fixed wing and multi-rotor. So basically, it can vertical takeoff and landing, and when it operate flight, it can fly like a fixed wing. So it can help it save more energies and also battery. So the next one we're going to talk about is the payload. There are many types of payloads in the market. So basically, the common one we call integrated RGB, red, green, blue payload. So this payload normally referring to something like our phone cameras will be similar as our phone camera, just have a different resolution and pixels. And then coming with like thermal, high zoom and multispectral camera that are for different type of industry usage. So the camera related to today's topic will be discussing about the multispectral camera. Then we also covering like other payloads to attach on the drone as well, such as the LiDAR, gas detector, supply box, and loudspeaker. So last but not least, the next slide we're going to talk about is the software. So after having the hardware, drones and cameras, we need to have a software to operate it, process and analyzing it. So over in the software part, we separate into three sections. So including operations, processing, analysis. By using different software, we will coming up with a different outputs. It depends on your client needs and also what's the output they are looking at. So next slide. So after talking about the basic idea of how drones being operates and process analysis, then today we're gonna covering how drones can be transforming the agricultures or the plantation industry. So basically, in applications of drones in oil palm, basically there are two main functions. So the first one will be calling analytics, basically providing different analysis to the plantation owner, and the second part will be calling automations. Basically, we'll be using the automation of the drone spraying drones to replace on the manual workers. So start with the mapping analytics. How it works is that basically it's very simple in three steps. You need to first deploy your drones with the flight planning. After that, you collect the data and acquire the data, and then you process and upload it into your cloud and also your platform. Then after that, you can do the further analysis by generate out of different outputs for your usage or your client further forecasting issue. So there are different kind of output will be generated. So in the next slide, I'm gonna show is a contour map. So basically, contour map is showing the contours of the plantations. Basically, it will show the different heights. Then we continue by the DTM, which is the digital terrain models. So by different colors, that it will show different heights of the land, and then continue by digital surface map. It will be similar. The different colors will be showing different heights of the land as well. So this is some of the output is generated by our teams. So, and also you can do a combinations of contour map and also DTM map together, something like this. So basically you have a combination of information, depends on your needs, what kind of information you want to look, and also what kind of analysis you want to see in your output. And then last but not least, also we have land use map. So basically land use map, you can see that in the picture that we have actually do the tree counting for our client. So this tree counting is very important for all the oil palms player because they want to know what is the oil palm is planted in the area and what's the area can produce, what's the productivities, or can be using the palm oil quantity to do the calculations. So basically we will draw out the boundary and also the rivers and also the infrastructures details, and also we will put in the vacant land, which you can see in the light blue color. So those are the informations we can input into the analysis part. Then the next slide we'll be seeing is the overview map. So basically after having the information of the land use map, then we can put in the overview map as in. You can our team can be helping the clients to coming up with the hectareage of the plot lots numbers and input in back to the map itself. So you can see all the block boundaries and also what is the hectareage covering by the boundary and also the plot itself. So basically this information can be done by our team as well through the analysis part. And then the next one, what we can develop as well will be the route network map. So basically route network map, we will draw out all the infrastructures map in your plantation. So in the examples that actually what we have done is that we draw out the rivers, the routes, the vacant land, and also some buildings inside the map as well. And also we do have some nursery area and also the field area. So all the informations or the infrastructures can be drawn inside the map itself through our teams. So this is the output that we can generate by our team. So after knowing that what kind of output we can generate, so now we're gonna talk about how we can acquire the data. So in here there are two types. So for the first type, we are talking about the small scale mapping solutions. So by having the small scale mapping solution, we need to have smaller drones, so which doesn't require have a high capability to capture for the for a bigger land. So what will be the suitable choice is Mavic 2 Pro and Phantom 4 Pro version 2. So for the small scale mapping solution, which is suitable for the for the land that is less than 10 hectareage. So basically per flight of the drones Mavic 2 Pro or the Phantom 4 Pro version 2 can cover up to 40 to 60 hectare per flight, which is the flying time is around 20 to 30 minutes. Then for a day after the operations, basically it can cover up to 300 to 400 hectare per days and also per drones. So if you are having more drones, basically you can cover for more area and also more hectareage. So this is more suitable for the small scale of mapping. So the next one, what we're going to talk about is a bigger scale, large scale of mapping solution. So for the large scale mapping solutions, basically we are looking at more than 10,000 hectareage of the land. So basically we're talking about the big lands for the oil palm plantations, which owned by those tycoon companies or the big GLC companies. So basically for the model that we are looking at to use is X-Swift and also X-Chimera in this situations. So basically for the drones, it can cover up to 600 to 800 hectare coverage per flight. And also for a day of operation, it can cover up to 2,000 to 3,000 hectareage per day. So basically this one is applied for the bigger scale of land. So talking about the specifications of the X-Swift, so this is the VTOL that actually we are distributing. So basically for the speed, it can go up, the cruising speed of the X-Swift can up to 90 km per hour, and the maximum payload, it will be taking 1 to 3 kg. Then normally we are carrying the Canon's cameras, and also the minimum radius that it can cover is 50 km, and also the endurance for the flight is around 120 meters, and maximum takeoff for it is up to 10 kg. So this will be the talking about the survey and mapping. So after talking about survey mapping, then we will go into the another type of analysis. So just now we are talking about mapping analysis, what kind of overview map and also what kind of contour map we can generate. But in here, we're gonna talk about is the multispectral solutions. So multispectral solution, we're gonna talk about NDVI. So basically, what it can done is that NDVI is the what we call normalized difference vegetation index. So from the pictures that we can see in previous slide, so the left one is capturing by the normal RGB camera, and also the right one is captured by the multispectral sensor. Yeah, I think it's a previous slide. Yep, this one. So the left one is the RGB camera, and also the right one will be the multispectral camera. So RGB camera is showing that is the normal picture of the oil pump itself. However, for the right hand side, there's multispectral camera is capturing the healthy of the oil pump. So what you see in the red color is represent there's something wrong with the health of the oil pump itself. So it can help to identify what there are some disease it happens or outbreaks in the oil pumps area. However, in terms of what kind of disease we cannot tell for now due to the technology's limitations. So next slide. So to understand what is NDVI, so for we must understand what is electromagnetic spectrum first. So in the picture is showing that there's a range of all type of electromagnetic radiations. So generally visible light is the radiation that our eye can see, and the color cameras can be captured, which is called red, green, blue, RGB. However, there are some other radiation which we cannot see, and also the normal camera cannot capture, such as the UV or the IR radiations. So what multispectral camera can capture is all this kind of light. So next, what is the mechanism behind the NDVI is that a healthy vegetation usually appear greener than the unhealthy one. This is because the chlorophyll absorb more blue and red radiations by reflecting more on the green radiations. That's why what we see most of our plants are in the green color. So when it calculates as a green color, then show that is the healthy plant. And when the color is coming out is a bit reddish, that means that the plant is unhealthy. So what we can see through the NDVI in the next slide is that we can see there's a heat map in the plantation. So when you're doing the analysis through the multispectral camera, actually you can see there's a dotted areas, or there's a red color areas, means that there's something wrong in the plantation. So basically, after you seeing this, or after you doing the analysis or the operations, then you can send down your teams to check what's happened over the palm tree. And also the next slide, what NDVI and also multispectral can do is that it can help you to identify the problematic spot. As we know, the plantation is a very big area. So by seeing on our bare eyes, we cannot see what happens to the oil palm trees. So by using the multispectral cameras, actually we can have a total overall or the overview of our plantation map, and seeing in the different colors that actually in the red colors areas that is the targeted area that we want to rectify, and also sending the treatments down to the plantation itself. So by using this method, we can save a lot of time and also reduce wastage by applying the right chemicals and also right solutions to the oil pump itself. And also we are having the GPS locations through our drone itself, then we can identify the problematic area correctly. So in this scenario, what is the proposed solutions that we're going to propose is DJI Phantom for multispectral. So basically, DJI have come out have come out with the solutions that the camera equipped directly with the multispectral camera. So basically, for the camera, it have a 6 lenses, which covering the red, green, blue, RGB, and also the red edge. I think yeah, I think the slide got some issue, right? Thank you. Sorry, just hold on for a while. There's some technical issues for the slide. All right, yeah, we are back on slide 30. All right, thank you, Afiq. Yep, yeah, so continue back with the cameras. Yep, so basically if covering the six type of cameras, red, green, blue, visible light, and also red edge and near infrared. So for the 5 band of the camera can help to do different kind of analysis, which later I will show what kind of output we can provide. So basically for the Phantom 4 multispectral solution, able to give us the live view. So this is very useful for the on-spot checkings on the craft itself. So as you see in the pictures, when you scan through the plantations, actually you can have a live view on your screen as well. So you can see the colors, NDVI colors that shows on your plantations. So it's very useful. So and also it did have 2 different views. So the first one will be the RGB, and then the second one will be the NDVI live view. So basically you can compare what is the RGB normal bare eye view, can see by our eye, and also what is the NDVI view. And also for the Phantom 4 multispectral is integrated with the sunlight sensor. As we know at the plantations area, when we're doing the data capturing, sometimes we might affected by the sunlight, which will show the different colors of the plants. So by using the Phantom 4 multispectral can help to maximize the accuracy and consistency of the data corrections during the mission flow at the different times of day. So this is the features of the sunlight sensor. And then the next one we're going to talk about is the centimeter level of accuracy. So by having the Phantom 4 multispectral, it comes with the RTK module and also the time sync model. Basically what it means that it can help you to get the real-time and accurate position data up to the cm level. So basically you can know where is your oil pump or what is the location of your oil pump, very precise and also correct. So this is another features in the Phantom 4 multispectral. So basically here are some key features is having by the Phantom 4 multispectral. So first one will be the 6 camera lens, as I talked about just now. Then the sunlight sensor, also RGB and NDVI fit, live fit view, and also the camera is stabilized by the 3-axis camber, which means it's very flexible, and the sensor are in the 2 megapixel. So some of you might think 2 megapixel is very low resolution, but in the market for the multispectral sensor is for around 1 to 1.5 megapixel. So for the 2 megapixel is considered a very good standard of the multispectral camera. And for the flight time, it can up to 27 minutes flight times, and also the transmission range, it cover up to 7 kilometers. So after seeing the key features, so now I'm going to show you what kind of a result can generate by the multispectral camera. So the first one will be the 2D auto mosaic map, which is the normal view or the RGB view from our eye. The second one will be showing the NDRE. Is one kind of the analysis that using to estimate for the vegetation health by using the red bench. So it's very useful for estimating the crop health in the mid to late stage of the growth where chlorophyll concentration is relative higher. So this one is referring to the paddy crops. Yep. And then for the second one is called NDVI. So NDVI are also usually using to measure the health vegetation. So the result will be generate the value between -1 and +1. So the value of the NDVI is higher, means the plant is showing better health, and the lowest will be showing the poor health. After talking about NDVI, the another analysis can be processed and also analyzed out is the Osavi analysis. So Osavi is called as the optimized soil adjusted vegetation index. So the algorithm normally is used for the canopy background adjustment for the factor of 0.16 to account for this visible soil in the survey area. So this is another kind of result can be generated. There are more kind of result can be generated. It depends on your team. They are looking of what kind of result in the analysis. Yep. So before I enter to the second part of the automation in oil pump, so I have finished my first part of analytics. So do we have any questions, Afiq, from your side that we can answer for our audience?
I think for now there's not any is not any questions from our audience. So everyone, if you have any question, just ask away on the right hand side of the screen. There's a chat box there. Then me and Jaya will answer it.
Yep. Thank you, Afiq, for checking for me. Yep. So I continue back with the automations in the oil pump. So the automation idea is that we want to use the drones to reduce the reliance on the labor. So in here, we're happy to introduce to you guys our Pola V16S models, which is our spraying drone. Is powered by our R&D team, Poladrone teams, and also engineered by our Poladrone teams. So basically, for the drones, the usage of it is mostly for the paddy and also oil pump. You can do for blankets and also spot spraying. So for the weight of it is around 34.6 kg for the takeoff weight, and also it can fill up to 16 liter of tank. And then there's for the flight time of itself is around 80 minutes. And also equipped with the terrain radar sensor, which is you can apply the drone spraying at the hilly side. And then for the control range is up to 1 kilometer, and the speed of it is around maximum speed is around 6 minutes per second, and also the spraying rate will fall between 1 to 2.5 liter per minute. So for the automation side, as I mentioned earlier, we are targeting on the blanket spraying and also spot spraying. So blanket spraying, there are two usage in the plantation. So the first one is to use for the disease of bagworms. So basically we will apply for the blanket spraying, put in the paddy sites, and then to spread around in the plantation area. And then the second spot spraying, the second method will be the spot spraying. So spot spraying, we normally are using it to for the disease of Oritus rhinobitis. So for the blanket spraying methodology is similar as the paddy or the flat crop spraying. This one is more applies to the smaller plants such as the paddy, which is commonly used, and also it can continues to monitor of the altitude. So it doesn't need to change of the altitude very frequently, and you can spray in the blanket methods. So this is for the blanket spraying methodologies behind. And then for the second methodology, what we're going to talk about is the spot spraying methodologies. So basically this is more we need to do further planning. So first we need to do area mapping first, and also filtering for the coordination of each of the plants for our client. Then after knowing the plant locations or the oil pump locations, we're gonna plan out the flight path of the spraying drones into the map. So as you can see in the second map, you can see each of the oil pump is tagged, and also we know all the GPS of it. Then after that, the next slide we're gonna see is we were having the flight path designed by our system. It's generate automated. So basically, it will choose for the best time, also best efficiency. And then after that, we will go to the ground and then deploy our drone and also run it by itself. Then everything will be in automated, so we doesn't need to be manually flight the drones. However, for changing of battery and also refueling the pesticide, we still need to have the manuals workers at the sites or the pilot at the sites to monitor for it. And also it will be better that to have someone to monitor for the drone if they have any malfunction of the drones. So that will be our suggestions. So, and also for the PV16S, we have plugged in with the management software in the next slide. So for the management software actually can help to monitor and also monitor your worker performance and also come out with the management dashboard. So basically, you can monitor how many hectares have been sprayed in one day, and also how many hours, and also how many times it already spray in your oil pump. So everything will be recorded. So it doesn't like the old times, you need to record it by the papers and pens. So it's very useful for us to present the data to the management, and also we can check on the efficiency of the worker. And then on the next slide, we can see that there are some sample results. Yeah, so the sample result are showing that there's a droplets coverage. How is our PV16 coverage for the drones? And also where there's a result that we found that the depth after the spray means the method is efficiency by using the spraying drone to spray on the crops itself. So on the next slide, we're gonna show what is the comparison between the manual way and also the drones. What is the cost comparison? So basically, we have set up the scenario that the coverage for a day of work is around 8 hours. So for the manual way, we can cover up to 2 hectares, and for the drone, we can cover up to 24 hectares. Then we calculate on the labor cost per days, and for the manual one, we expect that it's around 100 ringgit per days. So it's roughly around 50 ringgit per hectare. And also for the drone itself, we calculate as 2 pilots, and the calculation will be around 8.33 per hectare. And also we included in all the depreciation costs and also the battery costs, which we're showing the calculation at the site. So adding around of it, comparing the manual and the drone way, what is the total cost is that for the manual way, we will be using around 50 ringgit per hectare, and for the drone, we'll be using around 30 ringgit per hectare for a day of operations. So this will be just based on our scenario and also our feedback from our client, what is the cost, and this will be the standard scenario. So for different scenario, the cost calculation will be different. But for in this case, this will be our calculations based on our estimation and also depreciation that we factor in. So for this side, if you have any questions that you want to ask further, actually you can mail to us or you can call us, so we can explain further to you how we calculate out with the efficiency cost. So for the next slide, I do a bit of summary. So for the next slide, comparing the manual and the drone way. I think can we go to the next slide? Yep. So hello, Afiq. Can we go to the next slide, Afiq? Okay. Just hold on. So just hold on. There's some technical issue. Let us adjust the slide. I think Afiq from our side cannot see the slide. Oh, you want to share from my side? Can everyone see my slide? Just hold on. There's some internet interruptions. Can see my slide. Okay, so never mind. Everyone just refer back to my slide. So for the conclusions that we are talking about comparing the manual and also the drone way. So the cost efficiencies for the manual will be around, for the drone comparing to the manual will be 1.6 more, and the tire efficiency will be around 12 times. And also the spraying efficiencies. So for the manual way, we can say that is subject to the performance, because for the manual workers, whether it's spray on the spot of the oil pump or not, we doesn't know. It depends on the experience of the worker as well. However, for the drones, everything is set in the system, so we can know that there's very consistency of the spraying. And also for the documentation side, what we can see that is for the manual way, they need to record down everything in papers and pens. However, for the drones, everything is recorded down in the system, so no one can be cheated, and also all the data will be in real time as well. So that sometimes in the manual way, some of the workers might not be spray all the pesticides to the pumps. They might be just halfway dump out the pesticide. However, for the drone, is a machine, so it just listen to the system, so we can prevent this kind of situation happen. However, for the health and safety risk, we can see that is for manual ways, there's some risk that because they are close to the pesticide and also the chemical they are spraying to the oil pump by affecting their health. However, for the drones, it's a machine itself, so it doesn't affect a lot directly to the human body health. So yep, so there's a update and also announcements for our audience here. So in the next coming months, or August or September, we're gonna have a new launching of a new version of our Pola V16S. So for the Pola V16, we have a new version of it. We have strengthened all the features and also the ability of the drone. So for this one, for you guys, please stay tuned for the new version of the Pola V16. We're gonna announce soon. Perhaps in the next month, we will be doing the launchings. So during the launching, then you guys will know what is the new drone features we will be covering up. So stay tuned for it. Yep. So before we end to the slide talking about our experience, so for Afiq, do we have any questions that we can answer for our audience?
Yeah, thank you, Jayang. So I think the first one would be one of us has asked, what about the efficiency of NDVI images, using it to check the nutrient deficiency inside the oil pump itself? So I think that you can answer this one on how NDVI can help on detecting it.
Efficiency. Okay, so for NDVI currently is only can give you a general overview of the health condition of the plantations, but you will be not able to check whether what is the problem due to the nutrient deficiency, like the pests and also etc. So however, in the end, you still need to send your operation teams down to the plantation to check what kind of disease is happening on the crops or the plant itself. So basically what NDVI can help you is help you to identify the disease happen area or the targeted area this might affect by the disease. So it cannot tell you what kind of disease has happened on the plant itself. Yep, I think that will be my answer for these questions.
Yeah, and then I think looking back, one of us has asked about the management software that we have shown before. I think what is the name of the software, Jim?
Which software again for?
The management software. I think it's management intelligent apps. Right? Let me show.
Okay, it's the DJI.
Yeah, this one.
Yep, I think the management software we are using back is DJI MG software. That's is original by the DJI itself. So will be same as the spring-joint of the Argus management software, which is called DJI MG Plus software. Yep.
Yep. So I think that's all for the questions. I think we can move forward.
All right, thank you. So now I'm gonna continue on what is our experience and also what is our service we can provide. So basically, the service we can offer is that the first one will be the turnkey projects. So basically, in turnkey projects, if let's say you have plantations that you want to do soil mapping, but you don't have drones or don't have teams to do for you, then you can look for us. So we will help you to come up with proposals, and also with all the costs is included inside. Then after that, we'll plan everything for you. Basically, we'll be provide the drones, the pilot, and also come up with the processing and analysis output for you. So this is A to Z solutions. So this is what we call turnkey projects. And also we will provide training and support for those organizations that are looking for to train up their pilots and also do their operations in their plantations to plantation to operate for the soil mapping operations. So we can support and also give the educations to them. And also for the procurement part, we are looking at to sell our DJI drones or other drones that you might be interested. You are looking at, then you can look for us. We can help you to procure it. And also last, we're going to talk about is research and development. So basically, we're having a heavy research and development in plantation areas, especially for the oil palm. So let's say if you have any inquiries, you are interested, you can contact us as well. Then we can discuss further on this. And also apart from the drone itself, we do have our online cloud platforms, what we call HEATMAP. So HEATMAP is a platform that developed by our Poladrone team. So basically what it can do is it can do the online processing and also analytics. So it's a platform that is for everyone. So basically how it works is that it's something like a platform that after, let's say you have a drones, but you don't have any software to process and also analysis for it. So here comes the HEATMAPs for you to do the analysis and processing. So how it works is that, let's say after you have a drones, you're capturing all the data. After that, you just put all the data into our platforms and also select it for the output you want. Then the platform will help you to generate and also process the outputs according to your selections. So what kind of output we can be generate is that I just mentioned just now, including the oil palm calculation as you see in the slide here, the oil palm calculations. Then also we can generate for the 2D map, the DTM map, DSM map, and also DEM map. So these are some of the example of the output that we can generate. So over here we can see record line digitization map, DSM, DTM, and DEM. So there are many kind of output we can generate as well, just that it depends on what's the output you are looking at. So this is talking about the HEATMAP. If you want to know further, you can contact us. We will guide you how to use it and also how to do for the analysis and processing. So our experience that actually we have met up to 500 hectare is covering in Malaysia and Indonesia. So mostly we are covering is in plantations, then followed by forestry and others industry. So that is end of our webinar for today. So so if you got any questions that you want to ask further, then you can drop an email to hello@poladrone.com, or you can call us at 011-3652 or 9069 for further inquiries. Yep. So I think I have finished my session, Afiq. So I'll pass back the mic to you.
Thank you, Jayang. So everyone, thank you for coming, tuning in to our webinar today. After this webinar, we'll be sending you a recording of this webinar and also the presentation slides that we have talked about in this webinar. And if you have any further inquiries, please let us know at hello@poladrone.com, or you can contact us via the number that is on screen. So I think that's all for our webinar today. We'll be also sending you out any updates on the future webinars or workshop that we'll be holding in future. And yep, I think that's all for today. Thank you, everyone.